Hey guys, my name is Shreyas and welcome to the first video in our course of AP Chemistry. We're going to be talking about probably the most important things in chemistry and all of science, and that is the scientific method. Now, why is the scientific method so important? The scientific method is very important because it describes the way that scientists think when they're trying to come up with conclusions. And it's very essential because this way of thinking has been used for many years, and it's why scientists have discovered all the things they have discovered today. So let's go ahead and talk about it. So what is a scientific method? The scientific method is a systematic process of answering questions. That's the most simple definition you can get there. So it's basically a way of thinking in order to answer questions. And it's not a way of thinking that's just random. It has a process to it in order to make sure that you can correctly validate your data. So the scientific method consists of this. The observation. The observation is where you go around and you observe and then you find out an interesting thing. The problem with the question is the question you ask. It's when you look at something and you want to go ahead and do some research on it. The hypothesis is an educated guess of the question. The experiment is what you do to test the hypothesis and see if it's true or not. Data collection is collecting the data from the experiment in order to analyze it. Data collection consists of qualitative data and quantitative data. Qualitative data is data which does not have numbers, and quantitative data is data that has numbers. So the easy way of remembering the difference is quantitative N, it has an N for numbers, qualitative has an L, so it doesn't have numbers. Examples of qualitative data would be things like color, taste, smell, emotions, things like that. Quantitative data would be things like graphs, physical numbers. So analysis would be taking the data you collect and then in order to prove a conclusion. So analysis would be using the data to come up with the conclusion. Let me give you an example of an experiment. Okay. So let's say I am working with my co-partner, Zane, and I am getting very frustrated with him because he is not doing the things I'm telling him to. So that would be my observation. So from there, I want to develop a question. Okay, I'm very angry at Zane, so I'm going to do what I can to inflict the most pain I can on Zane. So that would be my problem or my question. So I'm making a hypothesis. So I know that from my personal experiences as well as watching other people experience my pain, I know that if I punch people in certain parts of their body, it's going to hurt more than punching them in different parts of the body. So I know, okay, maybe the face, I know that hurts quite a bit. Maybe the stomach, that's probably going to hurt a lot. So I create a hypothesis. I say that, okay, I think that punching Zane in the face is probably going to inflict the most pain on him. So that would be my hypothesis. Now I'm going to test the hypothesis with an experiment. So I am going to go up to my test person, whoever that is, who's going to help me, and I'm going to punch that person in the face. I'm going to punch that person in the stomach. I'm going to punch that person in different places. That's going to be my experiment. And then I'm going to collect data from that. They can be qualitative and quantitative data. Qualitative data would be like punching him in that place and asking him how he feels about the punch. Did this hurt? Did that hurt? How do you feel? Quantitative data would be things like the force at which I punch him at, the actual force. And maybe how loud my test person screams, something very sadistic like that. All right, and then I would collect that in the analysis and see which place I punched him has inflicted the most pain, and then I'd make a conclusion. It could be something like, all right, if I punch a person in the stomach, that would be where I can inflict the most pain. And then I'd go to Zane and I'd punch him in the stomach. So you probably think at this point I'm some sort of sadist. That's just a joke. I just want you to understand these terms. Okay, so that's the scientific method. Now let's talk about another important thing, the difference between laws and theories. This is a very common misconception. Laws are a description of observed behavior, while theories are, wow, that's a typo. Theories are an explanation of such behavior. So let me give you an example. A law would be something you just take for granted. Let's say a law would be let me think of a law. A good example is the law of conservation of mass. So that law says that in any chemical reaction, the amount of stuff you start off with is going to be equal to the amount of stuff you end up with. Now, there's no explanation in that law, you just take it for granted. All right, the amount of stuff I start off with is the amount of stuff I end up with. So that would be a law. Now, a theory is an explanation of this behavior. So theory would be something like, all right, the reason why the law of conservation of matter exists is because of atoms, and atoms are rearranged, and they do this. So theories would be trying to explain those laws. And now in the scientific method, what happens is typically you run the scientific method over and over again. This is the scientific method, all the parts of the scientific method. And then once you get the same conclusion many times through many observations, that is when you can get a theory. So a theory is usually a well-tested hypothesis which has many data supporting it. And the thing is, theories are not always correct, and theories are changed all the time. And in chemistry, we're going to be talking about many theories which have changed. For example, the atomic theory, our view of the atom has changed with many years. So just stay in tune for all this interesting stuff. But for now, the scientific method is as simple as that.